Hi, I'm Dylan.
Hi, my name is Jacob. For our project, we use this color light sensor here. It's kind of cool. It's got actually 4 on-chip color sensors, a red, green, blue, and white. And then it has 4 onboard analog to digital converters which communicate to the Nexus board over the I2C protocol. So basically, let's see here. In terms of functionality, the code constantly checks the I2C color sensor, takes in about 5 to 10 samples, averages them, and displays the intensities on the LCD screen here.
And the way it works is when you first initialize it, it kind of has garbage just because it's not been calibrated at all. So the first thing you do is you want to go ahead and set an offset cover. So you cover up the sensor to get a dark reading, and you press the OK button, and so now it knows what dark is, and you can see all of the numbers went to 0. The next thing you want to do is a gain, so just expose it to light, which we're doing. And it's going to optimize gain and find the max level that it likes. And then the third thing that we did was white balance. So we're going to white balance, and it takes just a moment to go through each of the different sensors and decide its optimum sensor level.
Those are smiley faces right there for each color that it's completed. So now it's finished red and green, and blue takes the longest for some reason because the blue sensitivity on that sensor wasn't very good, so it needed a lot more gain compared to the red and green. But it finally finished, and now it has real-time sort of averaged readings. We discovered that it's pretty noisy in ambient room lighting, but in like a sealed box with controlled lighting from like its onboard LED, which I can turn on with this button here. That's a really good light source for detecting with, but when it's just like ambient room light, it's really noisy. So I tried to average it out with about 5 samples, but it still is pretty tweaky. But okay.
So visible and white light obviously has all the colors of the spectrum in it. So we have these color filters here, which will filter out all the colors except for certain wavelengths. So as you can see, when you put the red one over, they all go down some, but red stays a lot higher than the blue, green, and white. You can see the same thing with green, and the green will stay higher than the other colors, and blue. And then it can even make sure your logic is right and look at orange and see that there's very little blue compared to both red and green.
All right. Great. Thanks, guys.